Hello, everyone. My name is Liang. I'm from CoreWeave. Today, I'm going to present benchmarking distributed machine learning on the Kubernetes platform. So this is a benchmarking tool topic, not really test results about model. And this benchmark tool is for distributed machine learning training only. And it's running on the Kubernetes there. So it could help focus on the focus here, understand. So this is a little bit about myself. I've been working on at the CoreWeave, mostly on performance and reliability engineer for AI infrastructure. Have a ton of experience on Linux driver, kernel, and AI infrastructure side. So glad to be here to present. And here is a little bit about the CoreWeave. We are pure GPU cloud provider. We provide a purpose-built cloud for our customer to provide efficient and a stable cluster. So today we're going through some quick background on the distributed machine learning and benchmark stuff, and a little bit of background about how we maintain the GPU cluster, what kind of issues there we want to address, we want to fix. And we also do some, because we don't want to build repeat wheels there, so we did some shopping on the side. And eventually we get some our own idea there, how should we do the benchmark for ourselves. So let's begin. So distributed machine learning training platform, there are not so many options outside. Like Slurm, that's the traditional one, very famous. There's Ray, quite a new one. Other than that, mostly goes on the Kubernetes, Kubeflow, even there's KubeRay, Slurm, and also a lot of plugins there to help it running, like the QQ, and Volcano and the coordinator kind of a plugin to make it as simple as possible. Benchmark. So I think we don't need to talk too much about the importance of the benchmarking. We need a proper monitor, measurement, and analysis to get an efficient, stable cluster on the side. So but even for that, there are so many benchmarks outside. CPU benchmark, spec, and Kubernetes, just for the Kubernetes benchmark itself. And there's the famous LM model benchmark. All the SOTA models there will go through this kind of benchmark to prove how good they are. But our focus, again, is on the AI infrastructure, system machine learning, or platform kind of benchmark. We focus on the system itself, the AI infrastructure itself. And so now let's go to one step back a little bit about the GPU cluster. Like I said, CoreWeave is a pure GPU cluster there. I know, like if you work on the cloud before, you know like how difficult to maintain the cluster. Not to mention for the GPU cluster. I actually worked on both kind of cloud before. GPU cloud is way worse than the CPU kind of cloud there. But even this, like it's actually it's like when we see the cluster down or node down or broken, like it's scary, but it's actually not that bad. There's quite a scenario that we actually didn't see anything wrong, but it's still some issues there. That really tricky part. For example, like we've been through some pain point here. Like for example, when we upgrade things there, hardware, software, firmware, OS, there, we could see the performance difference there, sometimes big. We saw sometimes when we do firmware, the performance dropped 10% there. It filled all our monitor towards outside. That's so frustrating. And there's also some, not that much, like 1% or 2%. That's really difficult to track there. And also there's similar like the degrade, like it's not the full cluster down, but there's one piece of that cluster is not right. We got this issue, like our customer report us that there are 1,000 GPU cluster, they saw 5% performance downgrade. But there's nothing wrong there. There's no alarm, and it took us tons of time to bisect searching the nodes there. Eventually, we found there's actually a GPU has a lower performance on its NVLink connection, and even for that one node, it caused the whole system like a few percentage drop there. So that's really nightmare. The other side, I think that would be the performance engineer or research scientist favorite. Like we want to find out the limitation of the cluster. So we want to find the theoretical compute capability of that. We want to see the single different device, and so on. So yeah, this is difficult for us to do. But yeah, in order to do that, we think like what we should do to fix this kind of pain point. We're thinking like maybe we could build a control environment. We decide every hardware, software, and the workload we're trying to put on. So we know what will happen, and we monitor that, and we measure that, and we analyze that. So we could control everything there. And we want this is for distributed machine learning only. Yeah. We already have different tools for like single node or like a single node machine learning kind of tools there. This one we focus on distributed machine learning. And we want to do the online monitor and offline profile, and we want it automation. So now let's get started shopping. Like, yeah, we don't want to put the duplication effort there. So you will be surprised how many benchmarks outside. Basically, every kind of AI company or platform, they will provide a benchmark there. There's some famous one there. First one goes to the MMPerf. We actually provided a couple of MMPerf results, or submitted multiple results already. It's good. It has complete data sets, results, and there's tons of the model we could slide. However, it takes too long time, and the test result is complicated. I mean for the distributed machine training side, because it included the process and training and validation data. We don't care too much about that. We also go to the touch bench, and that is also a very good one. So many unit tests out there, and good coverage. Like if you want to add model, we probably go shopping there. But it's mostly torch focused, and like over the dashboard, and also don't have too many distributed support yet. So we go to the NVIDIA, the DDX cloud benchmarking. It has some good tests there too. Quite cutting edge models there, very good metric setup. However, like it's mostly Slurm focused. Also, it's quite long. So we keep looking, and we also found a Kubernetes here. It's actually from the Oracle design. I think it's actually have a good design. It has the customized dashboard. However, it's archived. It took us too long time for us to launch, like to make it work in the latest Kubernetes. So yeah. We also, yeah, this is the only form, but we actually look at more on the side. But yeah, we don't think it all fits our requirement. So like we focus on ourselves, the Kubernetes analysis. Yeah, let's don't pay too much attention to the name. It's just a name, but let's see what it could do. We mostly, yeah, we want the tool could provide the baseline results there. So we could do the cluster validation, and we also could do the offline. So we know how to improve it, and then we want to debug, like fix the issues there. So this is the design we currently have. It's quite straightforward and the simplicity here. So we have this configure. Yeah, we run it on operator. We designed this operator, KubeRay analysis operator there. It's based on the Argo workflow, and we will do some configuration before launch the job. We do like the share storage, PVC, and we also set up some. We want to control the environment, like we said before. So we are provide some kernel like system kind of parameter configuration. We will launch a daemon set later to configure our node there before running the real machine learning job. And then, yeah, we're using MPI operator to launch the job we are running. And we also have this dashboard. We can monitor it on runtime, in the runtime. After that, we actually have some profile there. We could like go deeper to the test we are running there. So we can do the post analysis. And yeah, it's purely open source native. Like we use a lot of ideas from the previous benchmarks there. But yeah, so like the Argo workflow MPI operator, and this is our Prometheus and Grafana plus DCGM, so we could track some the node situation. And this is the torch profile tensor board there, so we could do the more detailed analysis, goes to the model itself. So yeah, so I think it's still ongoing project there. We make it work, but we still want to like make a dashboard, integrate the dashboard there, so we could put everything together to control everything. And currently, like I show you the metric there, it's mostly node focus. We want to add some model kind of a level metrics there. So we create a correlation between the node and the model. It could help us to debug the issues quickly. Yeah, so far we're using the MPI operator. We only build one workload. We are using Megatron and build for the GPTG from the MLPerf. And we want to add more in the future for sure. The current thinking is Llama. We want to maybe Llama 70B there. We'll see how that goes. So yeah, definitely we using the stuff from the open source. We want open source aid that. Once we have we have a proper dashboard there. We'll release it soon. So yeah, this is all I have today. I hope you could find something useful, interesting here. Let me know if you have any question. Or
thank you.